So in the previous session, we have discussed the more about arrangements. So in this session, we will be discussing about the subsets. So, you can see here. So let's try to form the subsets and how these subsets are important in the counting. We'll come to know about this in this session. Okay. So let's say again, we have the set A, which has four elements as marked here, 1, 2, 3, 4 again, because we are taking this example very often. Now, how many subsets can be formed from A, which has 0 elements, which has 1 element, which has 2 elements, which has 3 elements, and which has 4 elements, right? So we will try to, write this. So we say R here is 0, 1, 2, 3, and 4, right? And we write the subsets here. So with the 0 elements, we can do it in a tabular base to get started. So this is R, which is the number of elements which are there in the subsets of 1, 2, 3, 4, right? Now, with the 0 element, we know that there is only one subset, only element which can be possible is 5, which we have discussed as the null set, right? So this can be done via number of ways. We can say here number of ways is 1, right? Now with 1, you can form 4 subsets, which are namely 1, 2, 3, 4, right? So please note, since 1 is an element, 2 is an element, 3 is an element, 4 is an element, there are 4 subsets which can be formed of one element from this set, right? So this can be formed via 4 ways. Now let's try to form the 2 element subset of 1, 2, 3, 4. So this can be done via this subsets 1, 2. Please note here, since this is a subset, so 1 and 2 are elements, so it doesn't matter whether we write it as 1, 2 or 2, 1, right? So there are only 4 subsets which can be, 6 subsets which can be formed is 1, 3, is 1, 4, then we have 2, 3, we are, left with few spaces here, so we'll have to write it more here, 2, 4, and we have 3, 4. So these are the possible subsets which can be formed from the 1, 2, 3, 4 of having 2 elements, 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, and 3, 4, right? So this can be done via 6 ways, right? Now let's try to form the 3 element subsets. So the 3 element subsets can be formed as 1, 2, 3, which we have done, I think, earlier as well. So that is 1, 2, 4, right? Then we have 1, 2, 4, yeah, 1, 3, 4. Again, we are left with few spaces, so we'll move this to here. And the last element, subset which can be formed is 2, 3, 4. Again, I will try to make a note. Since these are the elements of the set, so it doesn't matter if we write it as 4, 3, 2. So henceforth, in counting the subsets, the ordering is not important, right? So we have 4 ways of doing this, and if we have to for the 4 element subset, that can be done only via one way, that we write all the elements there, right? So that can be done via one way. So here you can see that we can form the various subsets. Now, in the counting again, as we have done like for interpreting it in a different way, so we are going to interpret this as something as a notation. So we say, so 4 is our number of elements here, so we say now again the counting can have different ways of saying. So let's try to say what are the ways we can say that. So it can be combinations. Find the all possible combination of 4 different elements or objects taken let's say 3 at a time, or we can say select 3 people from the set of 4 different people. Or the similar way, there is another word which is commonly used, is find the number of ways a committee can be formed. A committee of 3 people can be formed from 4 people. So all these statements lead to the same mathematical interpretation, because again it's like selecting, finding a number of ways of finding a committee, or find all the possible combinations. So all these words you will see very often in the problem sessions, but it all means the same, and we interpret it as NCR, right? NCR. Or there is another interpretation of this is NR. If there are if you have to select R elements, or you have to form a committee of R people from N people, then we write it as NCR. Or you have to select, find a combination of R people at a time from N people, then again it is an NCR. And so looking at these examples, we'll try to find the parallel again. So this is nothing but the first one, the 0 elements which we have counted here is nothing but 4. This is nothing but 4C0. So it says find all the 0 elements combination from 4 elements, right? So this is nothing but 4C1, right? Now this is nothing but 4C2, and this is nothing but 4C3, and this is nothing but 4C4 again, right? So you see that we have interpreted it in such a way, it is more or less, looking at how many number of subsets can be formed where the number of elements is 0, 1, 2, 3, 4 from a 4 element set, or let's say 5 element set. So let's take another example to make it understand very easily. So let's say I say find the number of combinations. Find the number of combination of 3 people from set of let's say 20 people, right? So that is nothing but 20C3. Okay, now we'll try to see from our multiplication principle how we need to what we need to do to compute this number 20C3, right? So if you have to say find the combination of 3 people from the set of 20 people, what you can do first is to arrange this 3 people from 20 people. So that will be nothing but by our multiplication principle again. So we are left with 3 spaces, right? So the first place can be filled via 20 ways. So one person is out, so we are left with the 19%, and then we are left with the 18%, right? So that will be nothing but 20 into 19 into 18, right? Now since this is our arrangement, but since we have to find the 3 people combination, the ordering is not important. So how these 3 people can be arranged among themselves? So we have seen that in example, this can be done via 3 into 2 into 1. So that will be done via factorial 3 ways, right? So we say that 20C3 is nothing but 20P3 divided by factorial 3, right? So I'll go back to one of the previous examples which we have seen in our arrangement. Yeah, right. So you can see here, from here you can realize that there are, so among four people we have to count the find the combinations which has the element of 3. So finding 3 subsets from 4 elements, right? So you can see here there are 24 ways which we have arrived using our, the specific method, 4 into 3 into 2. Now if we have three elements here, it can be arranged among itself in a 6 ways. You can see here. So it can be arranged as 1, 2, 3. So this will be subsets. If we have to write it as a subset, this 3. So it could be, right, 1, 2, and 3, which is same as writing as 1, 3, 2, and all these other ones, right? Because it is only formed from the number 1, 2, 3. So we are left with again only with the 4 options. These are the 4 options of 4 ways we can form these combinations. So that will be 24 divided by factorial 3, which is 6, right? Right. So that will be 24 divided by 6. That will be done by 4 ways. So that is equivalent to saying it is 4C3, right? So we have seen here that again this 1, 2, 3, 1, 2, 4, 1, 3, 4, and 2, 3, 4 is the only combinations where ordering is not important, are the things which are there. So we have done that earlier. So we say that finding a subset is same as finding the number of ways of arranging where ordering is not important. So first we have to arrange these numbers via multiplication principle. Then you have to divide in the number of ways this ordering can be done, right? So arrangement can be done. So let's say we say find, again let's take another example, find the number of ways a committee of 5 people can be formed from 10 people, right? So again this will be, first you try to arrange all these 5 people from 10 people. So you will achieve at this number 9 into 8 into 6. You have to do it 5 times. Then since 5 people are chosen at a time, so they can be rearranged among themselves into factorial 5 ways, because that is 5 into 4 into 3 into 3, 1. So that is the nothing but 10C5. So it again comes from the using of the multiplication principle, and it has nothing new is added here, but we are just trying to give the different kind of problems which can be solved using the multiplication principle and the addition principle and the counter-positive principles, right? Here we see few of the identities which are quite important. If you look at it here closely, this 4C0 and 4C4 are same. If you look at 4C1 and 4C3, they are same. So this gives us an indication that these are few identities which are used in mathematics. So we say NCR is always same as NC N minus R, where N is greater than R always, right? N is greater than equal to R. So this is one of the identity which is commonly used in mathematics, but you can try and experiment with the more and more such identities which are used in the NPR, NCR, and we'll go through that in our various problem sessions. So I'll try to end this session here, so that with this session you get an idea about what the subset is, and then from the previous session we have got an idea what the your arrangements are. So we will, in the next session, we'll be discussing few problems related to these two topics, and to get a more idea how this arrangement and subsets are used in counting principles and how we are going to use it. Please note, these are nothing but the using of the multiplication principle in a different way. So when you see the word committee, selection, you are going to use the NCR. When you see arrangement, how many ways numbers can be found when the repetition is not allowed, then you will be doing the arrangement thing, right? So we'll move to the next session. Thank you for this one.